these ideas of basic algebra. I'm going to go through the idea of expanding, factorizing, and simplifying. Hopefully we'll see as we move through these ideas and look at examples that this is applied to, this is a useful application for engineering. These rules of algebra, they're like the basic grammar of mathematics. And so if you're going to use mathematics in engineering, you need to be familiar with these little ideas of being able to manipulate symbols which represent numbers in algebra. So we have a number, a symbol, a letter, A, alpha, X, any symbol you like. These symbols represent numbers, which might be an obvious thing to say, but actually you have to be a little bit careful about it. What's wrong with this statement? First of all, what does that mean? 2 times whatever A is. But what does A represent? A number. 2A minus A, somebody in a little algebra test might write this answer. Is that right? What's the misunderstanding here? Why might somebody write that? Right, so that's like I've got a number 2 there, and I've got an apple, say, for the A, sitting on the table. Take away the apple, what am I left with? 2, okay? But what that means actually is 2 lots of a number. We don't know what that number is. Let's say it's 5. So what that means is 2 lots of 5. So if I take away 5, I must be left with 5. In other words, 2A minus A, 2 lots of A, take away 1 lot of A is A, whatever that number is. And that little thing is if you have this confusion in your head and you think of the symbol as an object rather than a number, it can cause problems. And it might seem obvious there, but in a very complex algebraic manipulation, you might easily make that mistake. So bear that in mind as we go through these ideas. A represents a number, not an object. Let's have a look at this. You don't need to write this down because it's all going to be on the video. Let's look at it and you'll see the examples anyway as you go through more. Here's a rectangle. It's been split up into 2 parts, one side and another side here. So 2 plus x, I could divide it here. And at that point, that's 2 long, whatever 2 is, 2 centimetres, 2 millimetres, 2 yards, it's 2 of something. And this is plus another length, which is x. We don't know what it is, so we'll call it x. And then the side of this rectangle is y. We don't know what y is, but it's a number. So here's a rectangle. We don't know this length, we don't know this length, but we do know this is 2 long. Can you see that the area of this rectangle is 2y? Because it's 2 times by this length y. 2 times y is 2y. And this is xy. So if I want the area of the whole thing, the whole rectangle, then it's going to be that area, 2y, plus that area, xy. So that's one way of representing that area. But if we look at the 2 sides here, y and 2 plus x, I could think of that whole length as being 2 plus x, and that whole length as being y. So surely I could also write the area as 2 plus x, which is this, times by y, which is this. So I could write it like that. Note the use of the brackets here. This means this whole bit, 2 plus x, has been times by y. So that expression and that expression both represent the area of that whole rectangle. Agreed? So in theory, they should equal each other. Now, these words help us to see how we can show that they're the same. If I expand this out, and that's something we do often in algebra, if I say to expand this expression, it's likely to have a bracket in it. And what I mean by that is multiply out the bracket. That means multiplying everything inside the bracket, all the terms inside the bracket, however many they are, by what's outside the bracket. So I use 3 here, 3 lines to mean this is equivalent to or the same as. So in other words, y times 2 plus x is the same as y times 2 is 2y plus y times x is xy. And now we can see that that's the same as that, because I've expanded it. Note, I could have written y times 2, y2. That would have been the same, because y times 2 is the same as 2 times y. But by convention, we always put numbers first and letters afterwards. So 2y, not y2, because y2 could easily be confused with y squared, which means something entirely different. And equally, by convention, we tend to write the letters in alphabetical order if there's more than one. So xy, not yx. But they are the same. So it's not wrong, it's just convention. So if we expand out brackets, we get this. If we factorize, what we're doing is looking at an expression and trying to remove from a bracket what is common to both, what number is common to both. And if you look at these two terms, y appears in both of them. So I can take y outside a bracket. And then I ask myself the question, what have I got to do to that y to get back to this term? I've got to multiply it by 2. So 2 goes here. Plus, what have I got to do to y to get back to xy? Times it by x. So x goes here. So what goes inside the bracket is what's left. And I've factorised that now. So I've said that 2y plus xy can be factorised to give that. And now you can see that that's the same as that. So in fact we've shown that they mean the same thing, but also you can see it here. You can see. Okay, you can see that that is the same as that. Expanding and factorising is something we often do. We often expand so we can simplify, that we'll be looking at in a short while. We often factorise to tidy up, but also to allow us to then do something else maybe, to see what things are the same so they can be cancelled and manipulated in other ways to simplify. So that all sorts of laws, reasons why we use these rules to help us manipulate expressions. Okay. So what about that one? I want you to just write down an expression for the area of that square, effectively. Okay? But try and think of more than one expression to represent that area. And I'll just pause this video for a minute and give you time to have a go. Okay, let's have a look at this then. So, 2 ways I can do this. And first thing I can do is think to myself, well, if that's x and y, then the whole thing must be x plus y. Because it's being divided somewhere. That's length x, say, between there, and that's length y between there and there. So altogether, I could write x plus y for the two sides. So if I think of it like that, I could write the area as x plus y, which is the length of one side, times by x plus y again. So I could write it like that, x plus y times x plus y. Did anybody come up with that? Good, a few nods around, a few nods.
2x and then 2y.
2x and 2y, yeah.
And then x and 2 and then y.
Yes, I can see. Right, so is this a possibility? We'll come back to that. Right, so we'll come back and look at that, and then maybe you'll answer your own question, okay? Now, another way to look at this is, okay, if that's distance x, then that must be distance x too, because whatever else, I don't know what x is, but there must be the same number, otherwise it's useless using x to represent it. So if x appears more than once in an expression, at least I know they're the same number. And so I'm going to have here a square x by x, wherever x is. But then, of course, it's going to continue like this. So I must have 4 areas that I could represent this by. What's the area of this square? X times x, x squared. In this one, I've got x along here and y along here, so that must be x times y, which is xy. Similarly, y times x for this one, xy. Y times x. Note by convention I put the x in front of the y, but I could just as easily have done yx. And then finally, y times y gives me y squared. So that's the area of the whole thing. So I can write the area equals this. Add them all together. X squared plus y squared. That's these two. X squared plus y squared. But xy plus another xy. So how can I simplify that? Say again? No, that would be xy times xy. This is xy plus xy. 2xy. Yeah, 2xy. 2 lots of xy. And you can see the 2 lots of xy there. So 2 expressions to mean that. What I need to do, already done it down there. What I've got to do now is to show they're the same. I want to expand this and try and see if I can get it to be that. I want to simplify this, factorize it, try and see if I can get it to that. So going this way is not straightforward. It's doable, but it's not straightforward. Maybe we'll leave that for now, and perhaps you could have a go at it yourself, see if you can get it out. But let's focus on this one for now. So we're going to expand x plus y times x plus y. Now, remember I said what expansion means. If I've got a bracket, I multiply everything inside the bracket, the x and the y, by everything outside the bracket. But in this case, it's another bracket. So effectively, I've got to multiply each term in this bracket, however many there are, by each term in that bracket, however many there are. So I just have to be logical about it and make sure I don't miss one. What I generally do is take the first term inside this bracket and multiply it by every term in the second bracket, however many there are. And then I go to the next one and multiply that by every term in the second bracket, however many there are, and so on. So x plus y times x plus y in brackets is equivalent to, so if I do the first one, x times x, x squared. x times y, xy. Y times x, yx, or xy, writing it conventionally. Y times y, y squared. I've multiplied every term in one bracket by every term in the second bracket. And now I try and simplify. At this point, I've expanded. Now I simplify. I look for terms that are the same and combine them. X squared, there's only one term involving x squared. There's an x in there, but it's got to be exactly the same before I can add them. So I'm looking for other terms that are x squared. This is one lot of x squared. So if I happen to have two lots of x squared, I could add those together to get 3x squared, but there aren't any others. So it's just x squared. However, there's two lots of xy, so xy plus xy, 2xy, two lots of xy. One lot of xy plus another lot of xy. This means one lot of xy plus another one lot of xy, two lots of xy. So this is equivalent to x squared plus 2xy plus y squared. And we've done it. We've shown that that is equivalent to that. Have a go at that one. Write expressions to represent that. Try and think of two expressions. If you can think of more, good. Ooh, by the way, we're going to come back to this, won't we, before we move on. 2x plus 2y. 2x. That means two lots of x. So that would be a line which is length x plus another length x is 2x. That's 2x. So if you write this expression, what you're doing is you're adding a line 2x long to another line 2y long. So you've just got a line, you haven't got an area yet. There must be some x must be multiplied by y in some way to get the area of the two dimensions. Okay, have a go at this next one. Okay, let's have a look at it. It would be convenient maybe to draw a line here. So I can split it into two rectangles. I could have drawn the line here. In fact, I could have put both in and split it into three. So I could probably come up with three expressions to represent this area. One with a line drawn here, one with a line drawn here, and then one with both lines in. So you might want to come back to this later and try and write down all three expressions and then prove that they're the same. But let's maybe just look at one for now, which is this one here. Well, I know that length is x. What I need is this length. I know that this length is y. What I need is this length. So the first thing I've got to do is to write down an expression for this side. Suggestions? Y minus x. Good. Y minus x would be an expression to represent that side. Have a look at it. See it. What about this side? Somebody else. What would that be represented by? Y minus x, same. Yeah. This whole side y, if I take away this length x, which is here, I've got y minus x. I've got that side. So that's expression for that. So now I can write down an expression for the area. I can write down the area of this rectangle, which is going to be y times y minus x, plus an expression for this smaller area down here, which is going to be x times y minus x. So that expression represents that area. Anybody come up with that? Or something? No? You see it now. The first problem, wasn't it, was just to work out, well, what is this? And then I can do it. Okay, what I want to do now is expand this by multiplying everything inside the bracket by what's outside. And then I want to collect together like terms, simplify it in other words. So I'll just pause for a minute while you try that. Try expanding this lot, then expanding this lot, and then look for what's the same and try and simplify it, collect them together. So I'll just give you a minute to have a go. Okay, let's have a look at them then. This first one, so I'm going to multiply y times y, which gives me y squared. And then I'm going to multiply y times minus x, which gives me minus xy. So I get y squared minus xy. Now I'm going to look at plus x times y, which is plus xy, and then plus x times minus x, which is minus x squared. So plus xy minus x squared. Could have written yx for xy because of convention. Can I simplify that? How? No. Minus xy plus xy is... Sorry? No. No. That's a number. I don't know what x times y. I don't know x and I don't know y, but I know x times y. Must be the same here and here, surely. So minus 10 plus 10 is 0. Whatever the number is, they're the same, so they cancel each other out, actually, altogether. And so I'm just left with y squared minus x squared. So the area is that. A good illustration of how the laws of algebra can turn something that looks quite complex into actually something simpler. Simplify, that's where the term comes from. Okay? Have a look at that.
So you're effectively taking away what would be x squared.
Yes, away from, exactly right, yes. Look at this, y times y. So if I drew that whole square in, that would be y squared. Now if I take away the area of the chunk that's missing, the x squared, I've got the area of the thing, haven't I? So I could have done it that way.
I was going to say, and that's, you could do work out
Yeah,
by
yes.
adding these on.
Yeah.
Then in theory give you as well.
Yes. And did anybody think of doing that at the start? Good. Excellent. And did you end up with y squared minus x squared? Well done. And you've just shown that, we've just shown that the other way gives the same answer. So if you did that, excellent. But if you didn't see it, the algebra actually shows you, doesn't it? And sometimes algebra in an engineering situation will do that. You'll end up with a complex formula. You'll use the laws of algebra on it, and you'll come up with a much simpler formula that works, that you would not necessarily have seen by looking at it. So it can simplify things. Okay. So I'll say